Hello everyone, myself Sumit Maheshwari, working as an assistant professor in ABS Engineering College. Today I'm delivering a lecture on numerical of star connection, which is the topic of a subject fundamental of electrical engineering. So this is our numerical. A balanced star Y connected load having 8 plus J6 ohm per phase is connected to a three-phase 230 volt supply. Find the line current and line phase current, line power, which is three-phase complex power, and power factor. So what is our star connection? This we are recalling. This is our star connection. This is the phase voltage and this is the line voltage. This is the line current or this is the phase current. So in a star connection, line current and phase currents are in magnitude is equal, and line voltage and phase voltage, that is root 3 times. VL is equal to root 3 times of VP in magnitude only. If our Z of these three branches are identical, so this is ZP, that is identical. So what is the formula used? VL and VP, this, and ZP. ZP is VP upon IP, or IP is equal to VP upon ZP. So this 230 volt is given line voltage, and ZP is given, that is 8 plus J6 ohm per phase. So here 8 is RP, resistance of this phase coil, and 6 is XP, reactance of this same coil. So what is the polar form of this 8 plus J6? This is 10 angle 36.87 degree. You can calculate by using calculator in ohm. So we have ZP, we have VL. So from the formula, this formula, we can find out VP, that is VL divided by root 3. So this is 230 divided by root 3. That is called, after calculating, this is 132.79 volt. We have VP, we have ZP. So by this IP is equal to VP upon ZP, we can calculate the value of VP, IP. So here IP, if we are taking VP, that is 132.79, with an angle 0 degree, and our ZP, this ZP is 10 angle 36.87 degree. So after calculating, this is 13.279 with an angle minus of 36.87 degree. So what is our power factor? And before power factor, we can say that our line current is equal to phase current. The value of IL and IP is equal, that is 13.279 ampere. Now we can talk about the our power factor cos phi. That is RP by ZP. That is 8 by 10, which is 0.8. Now we can talk about the power. For active power, three-phase active power, we can write the formula for P, three-phase, that is thrice of Vp Ip cos phi. These Vp and Ip are in magnitude. So thrice of Vp, that is 132.79, and Ip, that is 13.279 into cos phi 0.8. After calculating by using calculator, it is 4231.96 watt, or 4.232 kilowatt. Similarly, we can calculate reactive power. Three phase, that is thrice of Vp Ip sin phi. So thrice of Vp, again 132.79 into 13.279 into sin phi. That is, if our cos phi is 0.8, then you can find out sin phi by using under root of 1 minus cos square phi. So from this we can calculate our this, or we can also find out xp upon zp, that is 6 upon 10, which is 0.6. So after calculating this Q3 phase, that is 3173.973 VAR or 3.174 kVAR. Similarly, we can find out the apparent power. Apparent power, which is thrice of Vp Ip, thrice of Vp 132.79 into Ip 13.279. After calculating, it is 5289 by using calculator, which and the unit is volt ampere, or 5.289 kV. We can also calculate power, active, reactive, and apparent power. Complex power as three phase is equal to P three phase plus J times of Q three phase. So you can calculate P three phase by using thrice of IP square RP, and Q three phase thrice of IP square XP, and S3 phase thrice of IP square ZP. So this is the alternative method. You can calculate these three phase by using these three formulas. In next lecture, we can discuss about numericals on delta connection. This question is taken from J.V. Gupta, Basic Electrical Engineering, S.K. Katari and Sons, publishers.